purpose of this video is to address some common questions with dimensional analysis, and also to go through a few more example problems to make sure that we are all feeling comfortable with this process. Remember, dimensional analysis is something that is going to become increasingly important in chemistry class and also in future science classes you take. Now, I know that we can do a lot of these metrics and versions without using dimensional analysis, but the new portion in chemistry of the curriculum is the method of dimensional analysis. And so I want to make sure that everybody feels comfortable using this method when we move forward. So this first problem says convert 2.27 times 10 to the 15th nanometers to millimeters. So in dimensional analysis, the first thing we need to do is we need to identify our given value and unit. So 2.27 times 10 to the 15th nanometers is our given value and unit. So I'm going to start out by writing that to the left-hand side of my page. 2.27 times 10 to the 15th. And then instead of writing out nanometers, I'm going to put the abbreviation. And remember, when you're putting abbreviation, you need to put the prefix. Here that prefix is nano, which I indicate with a lowercase n. And then you also need to put the actual unit. And my unit here is the meter part, which is indicated with a lowercase n. So nm meaning nanometers. And then, since we're doing dimensional analysis, we know we're going to multiply by some sort of conversion factor. So I'm going to go ahead and put times and then a line so I can set up my conversion factor here. If it makes you feel better to have something in the denominator over here, you can put something in the denominator. You can put a 1 in the denominator because anything divided by 1 is still the same thing. The one thing that I want to remind you of is that you cannot put units in the denominator unless there are already units in the denominator listed in the problem. Up here it just gives us 2.27 times 10 to the 15th nanometers. If there were a unit in the denominator, then the problem would say per, or it would give a slash or a division sign. And that's what indicates units in the denominator. And we will talk more about that when we get to zone 4 of our course matrix. But for now, we're just going to leave a 1 in the denominator. And then we need to set up our conversion factor. The unit we want to have cancel needs to go on the opposite side that it's on currently. Nanometers is currently in the numerator. And we want to put it in the denominator so it will cancel out. So I'm going to put nanometers down here. And then the unit we want on top of our fraction in the numerator is the unit we are converting to. So looking back at our problem, it says we're converting to millimeters, which it already gives us the abbreviation here. So I'm going to put millimeters in the numerator. Now what I need to do next is fill in my values. And to do that, I'm going to look at my King Henry died by drinking chocolate milk micro nano. I'm going to write that over here. King Henry died by drinking chocolate milk micro. I'm going to put 2 spaces in between micro and then 2 spaces in between micro and nano. So, first I need to determine which of these 2 units is the bigger one. And the bigger unit is going to be the one that is further up my metric chart over here. So nano's all the way here at the bottom, and then milli is right here. So my bigger unit would be millimeters. So I'm going to put a 1 next to millimeters. And then I need to figure out how many nanometers there will be in 1 millimeter. So I know it's going to be 10 raised to some power, so I'm going to go ahead and write that 10. And to figure out what my exponent is, I'm just going to count the steps between nano and milli. So I'm going to count 1, 2, 3, 4, 5, 6. So 10 to the 6th nanometers in 1 millimeter. Now, one of the other most common mistakes people make here is instead of counting the steps, counting from the space between nano, the spaces between each of the units, they tend to count the units. So they go 1, 2, 3, 4, 5, 6, 7. And as you can see, that doesn't get us the right answer. We are not counting how many units there are. We are counting how many steps we need to take to get from nanometers up to millimeters. So last but not least, we just need to cancel our units and then multiply and divide to our mass. I'm going to put an equal sign. My nanometers cancels out. I'm going to be left with units of millimeters, so I'm going to circle that so I don't forget to write it later. And then I have 2.27 times 10 to the 15th. I'm going to use my exponent powers here and cancel this 10 to the 6th. 15 minus 6 is 9. So I know this is going to be 10 to the 9th up here now. So I know my answer is going to be 2.27 times 10 raised to the 9th millimeters. Now, if you didn't understand what I did with the exponents just then, go ahead and just type this into your calculator. Type 2.27, hit the button, either it should say E or times 10 to the x, or maybe times 10 to the n. Hit that button and then put the exponent 15. Then divide, hit the divide sign. Open up a set of parentheses and put 10 and then hit a button on another button on your calculator. It might say x raised to the n or n raised to the x. Hit that button, that will open up an exponent. And then put your exponent 6. Get out of the exponent, close your parentheses, and then hit equals. And it should give you 2.27 times 10 to the 9th. Okay, in our second example here, we are going to convert 7,680 micrograms to grams. So we're going to start out by identifying our given value in unit, 7,680 micrograms. And I'm going to write that all the way to the left-hand side of my paper, 7680. And then I want to abbreviate this unit. And to do that, we need to know the correct abbreviation for micro. Remember, micro is not the same as milli. Micro is this funky looking symbol, the Greek letter mu. I'll write it up here, mu. And the Greek letter mu looks like this. You start at the bottom, draw a line straight up, and then make a U at the top. And that is the Greek letter mu, which symbolizes micro. So 7,680. I'm going to put micro, and then I have to also put my unit, grams, micrograms. I'm going to go ahead and put a 1 in the denominator, so I have something on both sides of my fraction. And then I'm going to multiply by some conversion factor. Since I want micrograms to cancel out, I'm going to put that in the denominator of my conversion factor. And then I'm trying to convert to grams, so that is what is going to go in the numerator. Next, I need to decide which unit is bigger. So looking at my chart, I see micro down here, and then grams is all the way up at the base unit. So grams is my bigger unit. I'm going to put a 1 next to that. And I need 10 to some power of micrograms to equal 1 gram. To figure out that power, I'm just going to count my steps. Remember to count the steps, not the units. So to count my steps, I'm going to count 1, 2, 3, 4, 5, 6. So 10 to the 6th micrograms in 1 gram. Now I cancel my units out, so micrograms is on top and micrograms on bottom. Those cancel out. So I end up with 7680 divided by 10 to the 6th. So to type this into my calculator, so on my calculator, I'm going to type 7680 divided by, I'm going to open up my parentheses, and I'm going to put 10, and I'm going to hit the button that says x raised to, and then it has a square on it. Hit that button. It opens up that exponent. I put in 6, I use the arrow key to get out of my exponent, close my parentheses, and then hit enter. And as you can see, the answer to this problem was 0.00768. And my units, I come back up here, look at my units, I should have grams. So I'll put grams. Now, if I wanted to, or if the problem asks me to, I can write this in scientific notation. Remember, I need to move my decimal point until I have a number between 1 and 10. So I'm going to move it so it's 7.68. 7.68. Then I put times 10 raised to some power. And that power is the number of times I'm moving the decimal point. So I moved it 1, 2, 3 times. My power is going to be 3. And I need to decide whether this is a positive or negative exponent. The number I have in my scientific notation is bigger than my original number. So to make this number smaller again, I need to make my exponent negative. So 7.68 times 10 to the negative third power, and that is still in grams.